Hey everybody, today's video lesson is going to be on the hydrolysis of salts. This video lesson I'm going to focus on the calculations regarding hydrolysis of salts. So when I look at a problem like this where I'm supposed to calculate the pH of a 0.3 molar sodium fluoride solution, first indicator that this is hydrolysis of salts is the fact that I have a pH that I'm looking for, but yet the compound I'm given has no hydrogen ions and hydroxide ions. So a lot of students right away think that the pH is going to be 7, but they have to realize that the conjugates are going to be involved in these reactions. So what I'm looking for are conjugate acids and conjugate bases of the weak acids and weak bases that accompany those conjugates. So to start this problem, since I'm looking for the pH, what I'm going to do is I need to find the hydrogen concentration somehow. And it's going to lie in the fact that I have sodium fluoride. Now remember, when I have sodium fluoride, it dissociates completely into ions. So in solution, what I'm going to have is I'm going to have sodium ions in that solution and fluoride ions in the solution, because this breaks down into ions completely, and basically you get the dissociation and all that other good stuff. Sodium is going to have no effect. It's really that fluoride ion that I want to look for. So what you're looking for when you're finding hydrolysis, you want the conjugate bases of weak acids. In this case, HF is a weak acid, and its conjugate base is that fluoride ion. So this is a conjugate base of a weak acid, hydrofluoric acid. Now, if I compare that to something like hydrochloric acid is a strong acid, so that conjugate base that I have from the hydrogen chloride, the chloride ion that I get from that hydrogen chloride, is not going to have any effect. So essentially, if I have any of the conjugate bases from strong acids, that would be chloride ions, bromide ions, iodide ions, nitrate ions, these are going to have no effect in any of the pH, because they're not going to be strong enough bases to do anything, because they come from really strong acids. Their conjugates are going to be so weak that they have no effect. So what I'm looking for here is I'm looking for the pH. So what's going to happen is that fluoride ion, when I put it into the water, is actually going to react with water. Remember, it's better to write HOH in here when you're doing the reactions with bases. And of course, that's an aqueous ion. And as a result of this reaction, what I end up with is HF, the weak acid, coming back, and more importantly, that hydroxide. Now, because this hydroxide is forming, that's going to dominate the pH. Whenever you have the hydrogens or hydroxides by themselves, they definitely dominate everything. So on this problem, I'm going to have an equilibrium. So I'm going to have a weak acid forming from the conjugate base. Okay, so the next step here is to start looking at the calculation. Well, I know that I have initially put into this container 0.3 molar solution. Water we don't care about. This starts off as 0. This starts off as 0. My change is minus x, plus x over here, plus x over here. And of course, the equilibrium table, we're going to finish up with 0.30 molar and x, and x over here. This pen is giving me a little bit of trouble. Sorry about that. Okay, so this is my setup for the ice table. Now, if I look up the Ka of hydrofluoric acid, because I'm going to need, in this problem, I'm going to get a Kb. So be careful with this. How do I know that this is Kb? Because of the hydroxide. So whenever I have that hydroxide in my, forming as a product, therefore what I'm going to end up with is a Kb problem. So that hydroxide indicates a Kb is going to be used. So I just go ahead and plug in. Remember, water doesn't show up, and I'm just following the same rules that I did for all of the other equilibrium. Now, what I need here is a Kb. Okay, this is where I was kind of jumping the gun here by writing Ka. What I need is a Kb, but I don't have it. If you try looking for it in a table, you're not going to find it, because what we do know is we know what the Ka is of our weak acid, because we know that this anion comes from hydrofluoric acid. So therefore, I can look up the Ka for the hydrofluoric acid, and that comes out to be 7.2 times 10 to the minus 4. Okay? Now, since I know what the Ka is, I can use the equation Kw equals Ka times Kb. Okay, what I can do is I can always solve for the Kb. You're going to have to do this when you're doing hydrolysis problems. There's no way around it. You just have to remember to find your Kb by taking the Ka and the Kw. So I'll do that really quick. Okay, so now I've got my Kb. What I'm going to do is I'm going to plug that all into the ice table over here and solve it like we do normal, everyday problems. So let me go ahead and do that. Okay, so when I solve for x, what I end up with is 2.0 times 10 to the minus 6 molar. And don't forget, because we're doing a Kb problem and we have hydroxide here, we've got to remember that this is the concentration of the OH minus ion. This is hydroxide, not the hydrogen ion. So if I take the negative log of this, I'm going to get the POH, not the pH. So you got to be careful with that. Don't forget that often students miss that step and they take the negative log and get the wrong thing. So I'll do that and I'll end up with my POH and then I'll find my pH from that. Okay, so when all is said and done, my pH comes out to be 8.31. Okay, so a couple things to remember when you're doing these kinds of problems is remember when you're looking at calculating pHs, you're looking for hydrogen concentrations. Well, we don't see them right away, and notice second that it's an ionic compound. It's usually an indicator that this is hydrolysis of salts. Break it down, look at your ions that you have left in the solution. What are your species that you have? Well, in this case, my species would be the fluoride ion and water, so that's why I react those two together. Those are the two major species. Set up the equilibrium. Realize that you have a Kb, not a Ka in this particular one. There's also hydrolysis of salts where you'll have Kas, and in that case, you'll have to find the Ka from the Kb. Plug everything in like you normally do. Don't forget about X being hydroxide, and then solve for your pH. So there you go, guys. Sorry about the pen. It was kind of a little sluggish there, but I think we did it. If you have any questions, let me know. I'll see you guys later.